Tower. Oh no, where is he? That's not what I wanted. That's the wrong one. In case you guys didn't know what the homework problems are, there they are. There we go. Aha. Number 4 should have been axis. Number 6 should have been negative. When the coefficient, leading coefficient is negative, you have a maximum. Number 10 matches with A. Axis, negative, maximum. Number 10 matches with A. Okay, number 24 is a bit of a party. Let me give you guys a second. But it wasn't. Oh, you did? Yeah. I had 24. And 54 and 58 and 76. Lo siento. Okay, so complete the square, your vertex, negative 8, negative 81. Sorry, I'll move my cursor to help you guys see it. Negative 8, negative 81. Axis of symmetry, remember, steal the H. The x-intercepts, a simple factoring problem, or you could have solved setting this equal to 0, no big deal. Would have been plus 81 plus or minus square root, which is plus or minus 9, and then subtract 8. Either way, you get negative 17 and 1. So put the 3 pieces together. Bump, bump, bump. Sweet, there it is. Is anyone still checking 24? Okay. Vertex, axis, the zeros are negative 17 and 1. Graph the 3 points and there you go. Remember next one? Are we going to the 50s or something? Okay. Yeah, okay. 54? Ooh, it was a fraction one. Did you guys get 5 halves and negative 3/4? But what was going on with this extra clue? This one was a harder example. Yeah, you were supposed to plug in. So, if you took the vertex, and if you made the y equals a, you didn't know what a was, x minus h squared plus k, you would have been stuck unless you used the extra points they gave you and plug that in as x and plug the y in as y. Now you can simplify and solve, just don't be scared of fractions. You should have gotten at the very, very end, a is equal to 1981st. And so you take what you know about the vertex, and you take the a, 1981st, and go ahead and make the equation. Now, if you're like, what about decimals? I don't like them. Unless it has to do with money or some sort of physicsy word problem. I should have kept those fractions. You can do that without a calculator. Anybody still checking 54? The clue was, or the key was, plug in what you know, realize what you don't, and realize you have an x and y that you can also plug in to solve for a. That was the key on 54. And scrolling down, you can still see the final answer to 54, but here's 58. Were they just asking for zeros? Look at you guys. Let's practice your factoring. Can anyone walk me through how they factored if they didn't do the guess and check? Because doesn't this just show the guess and check way? Pretend it's an arrow. This is the way I would have done it, going straight to the parentheses. But how would you do it with the x? You can't take out anything. What will go up here? Negative 6. You would have to multiply a times c, right? So 2 times negative 3, negative 6, and what goes in the middle? B, which is 5. And what factors of negative 6 add to be 5? Ooh, but hold on, don't I need a positive 5? Oh, yeah. I don't know where I was going. 6 and negative 1. Sorry, I was thinking that was a positive for something. What do we do with those, though? Do we just say x plus 6 and x minus 1? I have a number in front, which means these are my x terms, which means I need to go ahead and group. So I would do 2x squared plus 6x minus x minus 3. Do you remember what I told you to do before drawing the parentheses? Yeah. Make sure there's an addition of a negative and then close in. Because you need to make sure there's a plus in between, or else you might get confused. Hopefully you guys then pull out your 2x and have an x plus 3. Hopefully you pull out a negative 1 and have an x plus 3. Just in case some of you are still struggling out factoring, aka grouping. That's how we solve it, yeah? You didn't need that? Perfect. I'm really glad that you didn't need that, but just a few people probably did. At least a couple, so. I'm going to get rid of all this real fast. All right, kiddos. I think we have, what, 76? Is there another one, too? Just 76. Woo! That's a party. Let me zoom in. I know. You can say it was hard, but the question was, did you still persevere? Question isn't, is it hard? The question is, are you willing to still tackle it? Ooh. Anyway. Letter A, what were they asking for? The height when it's punted. You guys had to know. You can start frantically writing down answers, but it's not going to mean much unless you understand. I'm going to go ahead and quickly circle the answers. Because that's technically all you should be writing down if you didn't know how to solve, because you only write down the answers and then try to figure it out. There's A, there's B, and here's C. Okay. What clue can we know if we have an equation for the height based on, what did X stand for? Y was how high the ball is. X is, gosh, I don't know. Was it time or was it how far down the field it is? It was horizontal distance? Okay. So Y is the vertical distance, how high the ball is, and X is the horizontal distance, how far down the field from where it was punted. So, question, we don't know how high it is when it's punted, but what do we know? Why'd they plug in 0 for X? Yeah, it's before it's punted, or it's as it's punted. Has it gone anywhere yet if it's being punted? Horizontally. No, it's still back here. It hasn't gone down the field at all. The guy's still in the process of punting it. So we say the horizontal distance, how far it's gone horizontally, 0. Not that it's on like a 0-yard line, whatever that is. It's because it hasn't gone anywhere away from the punter. So we can plug in X equals 0 for A. It's simply a plug and chug. So 0 takes away that, 0 takes away that. 1.5 feet off the ground is how high the guy punted it. Which seems a little unrealistic. Maybe the guy was short. Anyway, letter B. Then it starts asking for the maximum height. Well, guys, what do we know about the max? It's the same thing as the vertex. And how do we find the vertex? Complete the square. These are nasty. So in this case, even I would have said maybe go to your calculator and get a decimal. I probably would have gone to the negative b all over 2a. Now, if you really did complete the square, I am so proud of you. Like, props, you deserve, I don't know, something. Show me all the work and I'll give you something. I'll get you, I have candy bars behind the board. There you go. I'll give you a bag of chips. If you actually did the by hand complete the square, props, way to go. But wouldn't it have made more sense if you were going to your calculator anyway just to throw in negative b all over 2a? Throw all that in, you can get the x. But they weren't asking for the x. Some of you might have stopped here. What were they asking for? Not the maximum, not the distance down the field of the maximum height. Not the x, but they were asking for the. So they have to take that x, I would have gotten a decimal, plugged and chugged it to the calculator, and then gone for it. Real quick, I had to actually remind calculus kids of this today, which is kind of lame, because they saw it in their pre-calculator graphing handbook. What's a fast way to plug in something to your calculator when you have to do it for a nasty equation like this one? Huh? You could still. That would be one way. But what else could you use? Nobody? Yeah, you could use the fraction box to make it a little bit prettier. Maybe it's not as big a deal in this one, but I would think that maybe it would be nice to plug that function into your, sorry, pre-cal did a regression-y thing today. Let me get out of that. Okay. Couldn't you just plug this entire function into your y equals? And once you plug it into your y equals, I'm just showing you an alternative. What can you do from the home screen to go ahead and plug in 365 45 over 32? You could do table. I was thinking this one. Do you guys remember how in the handbook I talked about how you can actually plug something in from the home screen? No, we don't remember that. Function notation, like f of x, like f of 2, f of 4, f of, what am I plugging in this problem? 365, 45 over 32. Now, yes, Eileen was saying a second ago, you could do 3,645 divided by 32. You could go ahead and stow it to be some random letter and just have to use the letter when you go to type it in. You could have done that. That's one thing you could have done. And then typed in b instead of typing in the variable or the fraction or the decimal. That's one way to stow it. The other way is you could have put your equation into y equals, and then to do the f of, you could literally use your from the home screen. Remember alpha trace. People with the yellow button, I'm sorry. You have to go vars, you have to go y vars, and then you have to go enter. That will get you your y1. But people with the shortcut, you can go ahead and just go alpha trace, hit your y1, and you could have plugged in your, what is it? 3645 divided by 32. Now, if you guys just did that with me, y0 is probably going to show the exact same thing that mine shows, which is, yeah, no. What did I never do? I never put in the equation. You have to put in an equation or it can't plug it in. But if you plug it in an equation, if you say go to, it'll say like, hey, look, I can't do this. Reason being, there's nothing there. But if you do have your equation in, it would plug it in for you. Anyway, I don't want you guys to forget that cool trick. It's a really helpful one, especially as you keep going. So I'm just reminding you of it. Because this one, you could have put in the equation and then put in this one time from the home screen instead of typing it all over again. Last but not least, what's going on here? The length of the punt. Okay. Come on, cool kids. You know football-ish. Why was it punted not on the ground itself? Why was it 1.5 and not like 0? His legs. Because, yeah, you bring it down and then you punt it. Anyway, never mind. So, I didn't think that was hard. So you punt it a little distance off the ground. It's not actually on the ground itself. And then it goes up in the air and it's parabolic and it comes back down. How are we going to know how far down the field it went? It's going to hit the ground and it's going to stop. Well, it's going to bounce around. But that's how far down the field it's going to go, right? So how do we find the x-intercept? We set y equal to 0. How do you solve the y equals 0? No way! What did they do? Well, I guess you could have done the quadratic formula. But if you're using your calculator anyway, didn't they use the calculator anyway? How do you find zeros of a function if you've already put it into your y equals to make some of this stuff easier? Just graph it and find the 0. Now, why would we not want this 0? The ball was never there, right? We want that 0. Hopefully that makes sense in context of the path of the ball. But just find the 0 on the calculator. Don't go stressing about the quadratic formula. Anyway, they were showing off there. And then when you solve, we don't want the negative one. If you would even have found it, we want the positive one, which makes a lot more sense. Any questions on 76? Because it's measuring from the person punting it, but not actually measuring like the yard runs. Does that make sense? But yeah, it would make more sense if you divided by 3 and thought about how many yards. That's okay. Whoever did this, I mean, they did this with the quadratic formula. I don't think they're really loving football too much. Okay, so let's get rid of this. Let's get rid of that. And let's move this guy over. Any questions? We covered the evens. Any questions on odds? Did I miss anything that you guys were stuck on? I'm going back to the beginning. Going once? Going twice? Worksheet time. Keep that color pen out. Let's grade. We already did the front all together, right? Worksheet. You can have your composition books close because we're going there soon. I have to go find the worksheet wherever he is. There he is. Did we already finish 6 and 7 also yesterday? Oh, we started but didn't totally finish? Okay. Let me go ahead and get you the answers for 6 and 7, 8 and 9 for you guys to grade. Hopefully it was pretty close. But then we need to talk about the other ones. All right. Number 6. I think we pretty much did this one, but that's okay. We have the vertex at 0, -8. We have the maximum of -8 at 0, and the zeros are none. Do you guys find none for number 6?
Yeah.
Cool. Number 7, we have the vertex to -5. We have a min of -5 at x equals 2. And the zeros of the functions should have been 2 plus or minus root 10.
For number 6, there is no zeros, but on number 2, when there was no zeros,
Oh, we could have done the imaginary ones. Is that what you're thinking?
Yeah.
So if we'd done the imaginary ones, we would have had plus or minus I square root of 2. Is that right? Hold on, double checking. You add the 8 divided by 4, -4, which is a -2, plus or minus square root, bring the I out. Yeah, it would have been plus or minus root 2, and that would have been technically plus or minus I root 2, comma 0. Let's go ahead and go down to 8 and 9. Anybody still checking 6 and 7? It's going away. And 5, 4, 3, 2, 1, 0. Oh, what was that?
After this, can we go back and go over the word for 7?
Number 8. How high is it at the maximum height? So we're trying to find the maximum value or the y value technically. When you went to complete the square, I got y minus 6 equals -1/8 x minus 4 quantity squared. At the end of the day, sorry, we don't put the minus 6 over here, do we? We've been putting it over here. Plus 6. So the maximum height would have been 60. Because the h is 4, the k is 6, but we're taking the maximum y value, the maximum height. So hence why we use the 6. It is at or when x equals 4, but maximum height is 6. And then for number 9, y minus 16, I think, equals, sorry, I think I did it wrong the first time and wrote over it. It looks like a 16. X minus 3 quantity squared. So once again, if you're doing the maximum height, that would be, I believe, 16 feet. You guys agree? Some are yes and some are still kind of wondering. Okay, what makes numbers technically 7, 8, and 9 all kind of hard? Because I made it look easier, I just wrote the answer down. Fractions. So at number 9, you guys would have had to really deal with that, right? Because you had to pull out what? With -4/9. This one you couldn't have mental math to, well, I don't know, maybe you could have. But when you factor something out, if you distribute in, you're multiplying. If you're factoring out, you're dividing. So if you're dividing 24/9 by -4/9, you're multiplying by the reciprocal. That would have helped you so much. So if I multiply 24/9 by -4/9, by -9/4, the 9's cancel, the 4 and the 24 becomes -6x. Now some of you would have also just looked at it and said -4/9 times what is 24/9. Maybe you would have gotten the -6 over 1. That could have worked. You might have mental mathed it, but just in case. And then when we want to keep going, what number fills in this blank, guys? 9. Good. Take half. That's the -3. Square it. That's the 9. But then what needed to come out here? +4, right? Why +4, not -4? So I multiply. I think I heard a lot of you guys, the 9's cancel. I think you got that. But remember, there's a -4 remaining. I have to do the opposite. Or think of it, if I did a -4 here, it's a -4 there. I would add it to the other side. And that's where I got my 16. Andrew, you had a question on the side? It's probably a pretty similar concept as far as what was difficult. But you guys already heard me talk it out. Number 7. Who can talk out how to complete the square root? One person, because yesterday we know we got a little crazy. Who's going to work it out for me? No, you don't. But you did do a lot of participation yesterday. Jonathan, go ahead.
Factor off 1/2.
Good. What'd you get inside?
X squared minus 4x plus 1.
And what you filling out here?
And then, minus 2.
Because you had to look at it. 4 over 2 is 2. I have to do the opposite sign, -2. And I would get to what was half of -4? -2. And -3 minus 2 is there. Okay. Any other questions on the worksheet? All the way through number 9. You guys ready for 10 and 11? All right. Whether or not, ready or not, here we go, number 10. I'm not going to work them both out, but I am going to give you guys the idea. And then you're going to finish 10 and 11 tonight. I know it's not specifically on the homework board, but we're going to check 10 and 11 tomorrow. Why is 10 and 11 harder? You already got hard, they were fractions, but what's even harder now? Where's the equation? We're mathy people, right? Like we want an equation and there isn't one. Struggle. So if there's no equation, we gotta make it. I bet the whole rectangular field, rectangular playground area has something to do with it. So what do they say? We have 500-foot roll of fencing. You guys know what those are, right? The big old huge rolls like in Home Depot and you have to like unroll it and then you get like the portable fencing around. Well, I guess it could be portable or not. Either way. The big old roll of fencing. What does fencing do? Go in or go around? Ooh, that's important. Okay, you want to construct a rectangular playground area. You guys want to, I don't know, put variables on the picture?
X and Y.
Sure, sounds good. So X is length, Y is width, something like that. X is base, Y is height. What are the dimensions? Doesn't that mean find X and Y, right? Find an X and Y of the largest yard. What's another way of saying largest? One of the words that we use in this worksheet. Maximum.
Oh.
They want to find the maximum yard. Question, is that an in or is that an around? What do they want to be maximized? The around or the in?
Around.
The largest yard. Isn't the yard the inside stuff? Where you play? Can't you play around? I think inside you have to stick on the fence. Anyway, you're playing in. So what mathematical geometric measurement is the in? Area. Snazzy. None of these words were used at all, but the concepts were there. They want us to find the X and Y, the base and height of the yard that would have the maximized area. Struggle. Do we know anything about the area of a rectangle? Base times height, or in this one, area would equal X times Y. Do you see quadratic yet? Me either. What's the one clue, the one piece of information that we haven't used? We've used the playground, and it's a rectangle, and it has an area, largest in dimensions. Right.
500-foot roll of fencing.
Anyone tell me what equation would have to equal 500?
2x.
Nice. It's the around. It's the perimeter. True? So what am I going to solve for? What do I need to get rid of? Anybody mental math it, or let me give you a couple seconds. You're doing your homework. Solve for what? What do you get? Yeah, you can do 250 minus minus x, you divide both by 2, right? So it'd be 500 minus 2x over 2. Don't broke it, and you have to divide both by 2. Both are being cut in half. So 250 minus x. You see quadratic yet?
No. Plug it in.
You see quadratic yet? You're about to. Because what happens when you distribute? Which is the same thing as negative x squared plus 250x. What are they asking for us to find of the area? The maximum. Isn't that just like the rest of the worksheet? You have a quadratic, they want the max, you do what you need to do to find it. Can you complete the square when there's not a third term? Yep. Could you always do negative b all over 2a if you feel lazy and confused? Yep. You're supposed to find the max. You can't do all the work for you. Number 11. What's different? 1,200. Oh, it's still going to be like fencing. 2 paddocks. Maybe they're having horses. Largest enclosure. Give you a hint. Alright, finished tonight. Let's go ahead and get into our notes. Did you guys see my hint? It was a very detailed one. Tons of info in that one. We'll see if you guys think carefully through. But the process is very similar. That's not you guys. I keep on passing you guys. There it is. The process is very similar. Oh, I forgot. I had these pages to do stuff on. Oh well. We did it in the video. We did it somewhere else. I can go copy and paste, I suppose. Did I erase it yet? Oh, I totally did. No, I didn't. Trying to get it so it'll be in the notes. Alright, kiddos. Get your table of contents ready. Section 2.3. Oh, 2.2. Just kidding. Don't know what I'm talking about. Alright. Optimize. There we go. I threw in the clue. Let's get rid of that guy. Oh, that's messy. Let's get rid of that and make it prettier. Okay. Polynomial functions of a higher degree. What does that mean? Higher than what? What was 2-1? Right. So where are we going to 2?
Cubic.
And quartics and quintics and septics? That's not right. Anyway, we'll stop. We're going to higher, guys. But the dilemma is quadratics. They're not super fun, but we have this formula, we have completing the square, we have factoring. And as long as we get the hang of it, it's not too bad. Do you guys remember from last year how fun was factoring a cubic? Or a quartic? Or a quintic? So, since the math gets harder, we're going to try and figure out as many clues, as much information about these functions just from their equations before factoring as possible. So section 2.2, we're trying to get as much information about these functions as possible because the math is harder. The factoring is harder. And we're going to have to deal with it. We're going to have to try it. We're going to have to do it. But we're going to try and figure out as much information as we can before. So what you guys are seeing is a few different terms and a few different ideas. That all polynomial functions, remember from section 2.1, all functions that are sums or differences of monomial terms with x to powers and coefficients. They're always going to be continuous. They're never going to have breaks or holes or gaps or vertical asymptotes. They're always going to be continuous. There's no weird piecewise jump thing going on. They're always going to have smooth turns. Sometimes the turns are quick. Like this one's a super quick turn. This one's more gradual. But they're always going to have smooth turns, even if they're fast. Some are going to be more spread out, some are more narrow, but always smooth turns. And if you guys notice, the red is an example of, okay, well, what's not a smooth turn? Absolute value of x is a sharp turn. It's at a point, it's at a corner. Yeah. Roughly graph by hand. Sadly, if I was able to teach you calculus in a day, you could graph exactly by hand, but I can't. And even Calc AD kids won't be able to get this exact graph until the end of first semester. But after they learn a lot of calculus, they will be able to get that exact graph. You guys will just, we'll try to get as close to it as possible without teaching you a semester of calculus. Sound good? So it's still going to be approximate. It's still going to be a sketch. But our goal is to be able to graph as much as possible by hand without knowing calculus. You guys have it? So the blue is the polynomial. I'll wait a little bit. The blue is the polynomial. The red is what a polynomial will never look like, or will never have. The blue is a polynomial. The red is what it will never look like. Kiddos, can anybody make a guess of the polynomial that you see? The polynomial you see is on the bottom left-hand corner, right? The polynomial you see. Can you guess what degree it has?
4, 5,
You're just guessing. It's not a quadratic. It's not a cubic.
5.
It's probably a 5. Could theoretically be a 7 or a 9 or 11 or anything that's odd and above 5. Why is it impossible to be a 4? Pause. Graphing calculators. They're going to have symmetry. I want you guys to graph any quartic that you can think of. You can put negatives in front, you can add different terms, you can add cubic terms, squared terms, x terms, numbers. You guys are all going to make a different example of a quartic. Just graph one. Has to have an x to the fourth in it, and that's the highest power of x it's allowed to have. You can put minuses, you can put pluses, you can put lots of terms, you can put 1 or 2 terms. Okay, and then I want you to get me a graph. You might have to play around with the window just a little bit. Hopefully you didn't put too big numbers, or else it might be a pain. I have to zoom out. I have to zoom box. The first answer I heard guessed for this one was a quartic. Okay. Question. Do any of your graphs look like just a parabola? Okay. It's possible. You didn't mess it up enough. The quartic can just look like a parabola, which is tricky because then it's like, oh, this is a parabola or a quartic or a 6th power, 6th degree, 8th degree, 10th degree. The problem is a parabola can be all sorts of different stuff. But does anybody's look like a W-ish thing?
No.
Does it have N? None of you got variation? All? Okay. Whose isn't a parabola?
Wait, ours?
Okay, so there's some loopy loops, right? Well, it's a part of it. Hold on. I'm not going to put the axes in, but in general, Jack definitely had fun. There's his. Where else? That is fun. Okay. Anybody else have a non-parabola? Everybody else have a parabola? Oh, you guys have to put some minuses in there. Okay. Question, did anybody have a downwards parabola? Okay. My question to you is, what's in common? We have, what, like 21 different kids? 21 different kids, probably at least like 3/4 of you graphed it. So let's say that we have about 18 different graphs. What's true about the insides of your graphs? Well, they're all different. parabolas don't have anything funky going on, and two people had really funky stuff going on. So the insides of the graphs, it's not all the same. What's true about the ends of the graph, though? How many of you guys have your graphs going up and up as you go to the right and to the left? How many of you guys have it going down and down as you go to the right and to the left? Okay, so if they can go down, what's in common isn't that they always go up, but what's in common with the 4th degree, 2nd degree, 6th degree, 8th degree, 10th degree, 22nd degree, 112th degree, 114th degree, every even function will always have the ends going the same direction. Every odd degree is going to have the ends going in opposite directions. So no matter what, I know that graph could not have been any even degree polynomial. Why did I make a big point of it? Because the first answer I heard guessed was a 4th degree. It's impossible. The ends are going different ways. We'll talk more about end behavior a little bit later. But once again, at minimum, ready? Watch. At minimum, this had to have been a 1, 2, 3, 4, 5th degree polynomial. Could have been a 7th or a 9th or an 11th that was only skewed somewhat. So if you guys look at Colby and Abby's, that one, can we count 4 different branches on it?
Yeah.
1, 2. This one I can count. 1, 2, 3, 4. On Jack's I can count 4. 1, 2, 3, 4. It had to be at least a 4th degree. This one, but pause, isn't it even? And it's not a parabola. So it couldn't be a squared. So what did it have to be at least? A 4th. But sometimes the branches get kind of skewed or kind of squished together so you can't see them as well. Anyway, that's why I say this has to be at least a 5th. Could have been a 7th or 9th or 11th. Alright, let's keep going. Oh my goodness, we basically just talked about this entire page. Because this says, for a basic monomial, which means stuff hasn't been all crazy, added and subtracted and distorted and all that sort of stuff. If n is even, if the highest degree, well, there's only one degree, it's a monomial, but if the highest degree is even when you start adding and subtracting, but before you start adding and subtracting, it's just going to look like a parabola over and over and over again. So basic parabola x squared, we know. If you guys got your calculators, an x squared is going to look a lot like an x to the 4th. An x to the 4th is going to look a lot like an x to the 6th. An x to the 6th is going to look a lot like an x to the 8th. What's happening as I start increasing the power?
It's getting sharper.
It's getting sharper because it's increasing, it's going up faster. That makes sense though, right? If I plug in 2 squared, it's only 4, but 2 to the 4th, pencil methods, 16, because 2 squared is 4, 2 squared is 4, and 4 times 4 is 16. What if I went to x to the 6th? 16 times 4 is 64. You were doing like something else. X to the 6, it'd be 64, but long story short, is 2 to 4 and 2 to 16 and 2 to 64 a lot different. But what do the graphs look like? Pretty similar, just getting what? Vertically stretched. Okay. But, question, what's true about all the ends? They're going the same direction. And how would, Janelle, how did you make yours go the other direction? What'd you do? She put a negative in the very, very front, leading coefficient, and flips, right? Okay, what if n is odd? What's a cubic look like? You guys know that one, right? So what's going to change if I do not x cubed, but x to the 5th? Yeah, it's going to go sharper. It's going to be narrower, because instead of 2 being raised to the 3rd power and being 8, 2 is going to be raised to the 5th power, and it's going to be 32. But it's still going to have the same shape. Does that make sense, guys? Mm-hmm. So all the evens and all the odds are very similar in their shape at their most basic parent function graph. What's in common, even if we start adding and distorting and all those sorts of things with different terms, We might have some funny stuff going on in the middle, but the ends are always going to follow the same ideas of even go together and odd go opposite. All right, let's keep going. We basically already talked about this page, too. I just went too fast. So if n is even, it's going to be upward facing parabola, true, no transformations. If n is odd, it's going to be a little swoopy doop like a cube that we just talked about. But what happens if a is less than 0, like what Janelle did? Yep. It's going to be vertically flipped, true. And odd, what's going to happen? Vertically flipped. Now, the pictures aren't necessarily supposed to be super hard. What's going to be a little tricky is how to do the notation. And how to explain what's going on without just pointing or graphing. Is Ryan the only one? Sorry, other Ryan. Ryan. Or Ryan. I think he was in luck. Now, what I do want to point out is, once we start adding other terms, once the function gets transformed, we're not going to be able to say that the middles are all the same. But what we are going to be able to say is, based on the leading coefficient, what's going on eventually to the right and to the left. But let's be snazzy about our notation. Let's be snazzy about our notation. We know intervals now. I'm just going to introduce you to a very important symbol in, well, calculus, basically. I'm going to say as x, little arrow means approaches. As x approaches. And I'm going to say as x approaches negative infinity, and I'm going to say as x approaches positive infinity. I want you to try to figure out what I'm talking about in much simpler terms. If x is approaching negative infinity, what direction am I headed from the origin on my graph? To the left. Does that make sense? So I'm going to the left. And what am I doing as x approaches positive infinity from the origin? To the right. And I'm not worrying about the little stuff that's going on in between negative 10 and 10, or maybe even negative 20 and 20. I'm not worried about the middle. I'm worried about the big stuff. I'm worried about as I go really left and as I go really right. So what can we say as we go really left and really right for this function? What are the y values doing? So I could say approaching infinity. Pause. Does that make sense? As x goes to negative infinity, what are the y's doing? Positive infinity. As x goes to positive infinity, what are the y's doing? Approaching positive infinity. Now, pause. What's going on if the leading coefficient of an even is negative? As I go left, f of x is approaching negative infinity. And as I go right, f of x is approaching 10. So here's a mathematical way of showing that the end behavior, what's going on the ends, or as I go or try to approach the ends of these different functions, they are in agreement. Even functions, the end behaviors are always in agreement. That's a mathematical way of stating it. So what am I going to show if I do the exact same table down here for the odds? As x approaches negative infinity to the left, as x approaches positive infinity to the right, what am I going to say for the first function? Pause, this one, to the left.
Oh, negative.
F of x, f of x is approaching negative infinity, right? What can I say for f of x as x approaches positive infinity?
Actually, also,
But it approaches the opposite infinity, right? Odd function is always opposite. And so what am I going to fill in for this one? As I go to the left, after the X is approaching. And as I go to the right, after the X is approaching. You see how the little arrow can help us explain where graphs are headed? Little arrow, what did I say it means? Approaches. I'm going to go ahead and show you the calendar quick because I hear you guys all packing up. We started section 2.3 today. What was our goal? Sorry, 2.2. What was our goal?
Graphs without calculators.
To start! So, we did start. Yay, go team. What's our goal tomorrow? Finish. This over does not do until Monday. Bye guys, see you later.
Like, you used to get a cheat. Or you start.